In this lesson, what we're going to do is go over firing the laser. So at the moment, we have the A button. When you press the A button, it makes the pew sound, but really what we want is a laser to come out and shoot at the aliens. So there's several things we need to take care of. First of all, normally you would be able to fire several times. We've already solved the problem of continuous fire. So you have to press the button and then release and repress. So we're ahead on that one. The next problem is that you have to remember that the Pi badge has very limited memory to be able to get the images on our screen. So we don't want thousands of lasers flying around the screen. So there's a couple things we need to watch for. The first one is when we fire the laser, it's going to move up, and it's going to move up and then off of the top of the screen. When they go off the top of the screen, we need to remove them from memory, so to speak. Because if we don't do that, then we could end up with thousands of lasers floating around off the screen, and they're going to be taking up memory. So to solve this problem, instead of adding and removing, which actually is a really difficult thing for the Pi badge to do, normally what we do in this case is we create the lasers right at the beginning of the game, but we stick them off the screen. So we have our screen here, and we know that this is the 0, 0 point in the top left-hand corner. And as we move to the right, it gets higher, and as it moves down, it gets higher. So what we're going to do is we're going to take the lasers, and we're going to create them, and we're going to stick them off the screen in a negative X and a negative Y location. So they actually show up off the screen. They're in memory, but we can't see them. And when we fire, we'll grab one of those and then place it where we want it to. Just for convenience sake, we're going to have 5 lasers so that they match the 5 neopixels at the bottom, plus 5 is a good number just so that we don't overload the Pi badge. We also have to then have a coordinate for what does off the screen mean, which is less than 0. And we need to make sure that we can keep track of when they go off the screen, then move them back to that staging area. So we're going to create a couple new constants. Here's our new constant list. We have ship speed, which moves our ship and our alien at 1. The lasers are going to move faster, so they're going to move at 2. Here is our off screen for X and Y. So as I said, negative 100 is going to be the definition for that in either case. Off the top of the screen starts at 0, but we want to make sure the bottom of the sprite is completely gone. So it's one whole distance of sprite size, which in our case is 16, so minus 16 off the top, and it'll be completely gone. It's going to become useful later on to also keep track of bottom of the screen, because we're going to have aliens moving down towards us. So that's what this dimension is. So it's the screen size plus a whole sprite as well to get off the bottom. So those are some new constants that we're going to be using. The next thing we're going to do is add in our images. So we already know how to add in spaceships, and we've done that before. We have a single spaceship and we have a single alien. For lasers, we have to have several of them, and eventually we're going to have several aliens, but for now we're going to have several lasers. So to do that, we create a variable that looks like this, and the square brackets represents that it is a list. We also need total number of lasers as a constant. If I don't already have that, I do. So total number of lasers, we're actually going to just set that to 5 because there is 5 neopixels on our screen, or sorry, on our Pi badge, so that's going to become useful later on. So the square brackets means it's a list. We've actually already seen this before with square brackets. If you remember, here we go. I said that the ship and the alien in the background, we had to put in square brackets to make them a list. So instead of doing that after the fact, our lasers actually are going to be a complete list. So lasers is a variable that can hold more than one thing now. Okay, so it holds several lasers. We're going to use a for loop, and we're going to go from 0 to, in our case, 5. So 0 to 4, 5 elements. And we're going to create this new variable called laser number. So this is going to rotate through from 0 to 4. We've seen something like this before where we create a single sprite. So we're going to create all these sprites. They're going to be the exact same image, which is image number 10. We're going to stick them in the exact location, -100, -100, and we're just going to create them and stack them up there. Once we create a single laser, we then append it or add it to our laser list. So we're going to enter our loop, we're going to create a single laser, we're going to add it as the first element, we're going to come back, we're going to create another laser, now we have 2 of them, and we're going to do this 5 times over. So this variable now contains 5 images of lasers. We then take that list and we add it to our very first printing of our images to our screen so that it shows up. Now what we have to do is every time we hit that A button, we need to take one of these lasers, if we still have some that haven't been moved over yet, and move it to where we want it to go. And the easiest place and most logical place to place the laser is exactly where our ship is, because we're firing from the ship. So the laser should show up exactly where the ship is. That would make sense for us. So we're going to go down to where we used to have, if A button was pressed, and we just had the pew sound happening. And now what we're doing is we're going to have another for loop. This len command just gets us the length of our list of lasers. So in our case it happens to be 5, so this will return, once again, we're having range 0 to 5. And then we say, hey, wait a minute. We can only fire one of those 5 lasers if it is still off of the screen. If for some reason we've already fired all 5 and they're moving up the screen on us, then we can't fire again. That's not going to make any sense because we only have 5 of them. So we go through our list of lasers and we check each one individually, its X position, and we check if it's less than 0. Because remember, we started them off being at -100, -100. So if there is one that is off of the screen, then we take that particular laser and we move it to wherever the ship happens to be, because that would make sense. As soon as we do find one and move it, we play the sound and then we break. So we're breaking out of this for loop if there is ever a single laser that needs to be moved over. Because as soon as we find one, then we want to stop. It's not like if all 5 of them are off, we put all 5 instantly on the screen. So that's why we have our break command that we've seen before, and that hops us out of this loop. So we loop over all 5 lasers. If we ever find one that is off of the screen, move it off to the screen, make the sound, and then stop instantly. The next thing we have to do is we have to check to see if we actually do have any lasers that are on the screen. Because remember, we are inside our gaming loop. And every time we go through the gaming loop, if there is a laser that is currently on the screen, we would need to move it up a little bit. So that's what the next section here does. So once again, we're going to loop through all of our lasers. We check each particular laser one at a time. This time we're checking to see if it is on the screen. If it is on the screen, then we move the laser up 1. Okay, so that's why it's the Y direction, and we are subtracting 1, because remember the Y direction increases as we go down the screen. So we decrease it, in our case, by 2, and that will move the laser up the screen. The next thing we need to do is we need to check because eventually that laser will get to the top of the screen and go off the top. Once it goes off the top, we then need to take it and move it off of the screen back to that -100, -100 section, location. So if we do have a laser that is currently on our screen and we've moved it up slightly, then we're going to check its Y location. And if its Y location is less than, because remember as you go down the screen it gets bigger, so when it goes less than off the top of the screen, then just take it and move it back to that starting point that we had before. So this section of code, once again, will check every single laser, see if one of them is off of the screen, or sorry, is not off the screen, but is on the screen somewhere. If it is on the screen, we're going to move it up, in our case by 2. Then we're going to check if it has gone off the top of the screen. If it ever goes off the top of the screen, move it back to the holding pattern. And then we need to render the sprites that are moving around on the screen. Remember the background is static, which in our case is our single alien, our spaceship, and our collection or our list of lasers. That's why it's not in square brackets, because this thing already is a list. It's not a single variable. And then our lasers will get redrawn to their new location. And that's how we actually get lasers to show up on our screen, move up towards our aliens, and if they ever go off the top, they get moved off of the screen, and it also prevents us from just having 5 lasers in total.